Right, good evening, everyone. Welcome to another session. Like I said, I'm going to be carrying on with the calculus. I've chosen two long calculus questions, and I think they are quite useful questions because these are the types of intricate ones that come up in final papers. Okay, this is actually from a past paper. Right, so this one gives you the graph's equation, right? But they also give you the sketch of this function. And so this falls under graph interpretation. And they ask you various questions based on the graph itself. So there are various things that you need to look out for when it comes to these questions. Things like, ask yourself, if they mention a letter or a segment, like if they say find the coordinates of P or find the length of AB, think of things like asking yourself, is this a y-intercept? Is this an x-intercept? Is this a turning point? Is this a point of intersection? Those are the kinds of things you need to be aware of. You need to preempt them, okay? Right, so they've given you the equation. There's no unknowns in that equation. They've also given you the shape of the graph, and they are now going to ask you some questions. The first question is, write down the coordinates of C. So in other words, look at C and ask yourself, what point does C represent? And if you look carefully, you'll see that it's where the curve cuts the y-axis. In other words, C is a y-intercept. And how do we find a y-intercept? We let x equal 0. All right? And if we let x be 0, minus 0 cubed plus 13, 0 plus 12 will be 12. Okay. And the coordinates of C, obviously, you need to write them as coordinates, meaning an x and a y. So x is 0 and y is 12. All right. So that's a nice, easy one, only 1 mark. Right, the next question says, calculate the coordinates of A and B. And again, ask yourself, what do A and B represent on this graph? Well, you can see that both A and B lie on the x-axis, and they are points where the curve cuts the x-axis. In fact, there are 3 such points called the x-intercepts, right? They are just very kind in giving you one of them. Right, it's a 5-mark question, so there's a bit of work involved. Right, so they are telling you that one of the x-intercepts is -1. And what is the method for finding x-intercepts? You let y equal 0. Right, so let's take this function and put it equal to 0. Right, and we don't like to have a negative in front of that first term, so let's divide through by a negative. And now we need to factorize, except they've given me one factor. They've given me a root of x equals -1, which means that if I take the -1 over, x plus 1 equals 0, and therefore x plus 1 is a factor. So that means that one of my factors is x plus 1, and I now need to find what's left so that when I multiply out, I get back to that. Now, there are various ways to do this one. You can do it by inspection. You can do it by long division. You can do it by equating coefficients, or you can do it by synthetic division. And I'm going to show you how to do synthetic division. It's a nice method to use. I think it's worthwhile looking at that method. So how synthetic division works is that you write down all the coefficients of x in decreasing powers of x. So starting with the biggest x to the power 3 is the biggest. There is a 1 in front. There is no x squared term, so it's 0x squared. Then there is an x, so it's minus 13, and then there's no x, which is minus 12. And we do the following. We leave a gap in that line because there are going to be numbers here, and our root is minus 1. That number goes there. So this value goes there. Okay. And what we do next is the following. We add down, so we add down and we multiply across. Okay, we start here. 1 and nothing is 1. So we add down and then we multiply across. 1 times minus 1 is minus 1. And then we add and we multiply. And we add, and we multiply, and we add. We have to end up with a 0 there. If you do not end up with a 0 there, then either your root is incorrect, this number, or you've made a mistake with the synthetic division process. Okay, so let's just go through that again. We write down the coefficients of my function that I'm going to solve in decreasing order of powers of x. So 1x cubed minus plus 0x squared, because there's no x squared term, then minus 13x, and then the number. So power 3, power 2, power 1, none. We add down. 1 plus 0 is 1, and we multiply. So add down, multiply up. 1 plus 0 is 1. 1 times minus 1 is minus 1. 0 minus 1 is minus 1. Minus 1 times minus 1 is 1. Minus 13 plus 1, minus 12. Minus 12 times minus 1 is 12. And if you add, you get your treasured 0 there. Okay. Now we started off with an x cubed, and one of our factors was x. So this term has to be an x squared. So it's going to be 1x squared minus 1x minus 12. X squared minus x minus 12. And of course, I can then factorize. Well, in this case, I can factorize this quadratic. It's definitely x and x. Factors of 12, let's subtract to give me 1, are 4 and 3. The biggest is a negative. So there we go. That's my factorized form. And therefore, x equals minus 1 or 4 or minus 3. Okay, so remember you put that equal to 0, solve for x, and the same for those two. And these are my x-intercepts. There's the minus 1. This one would have to be the minus 3, the negative 1, and 4 would be for b, the positive. And again, read the question before you carry on with the next question. Calculate the coordinates of a and b. Okay, so they need answers like a is minus 3, 0, and b is 4, 0. They want the coordinates. You can't just write 4 or minus 3. Okay, you have to put it in coordinate form. Right, so there we go. That is the x-intercept process. Okay. So very much using the whole concept of factorizing a cubic function. And when I get to actually finding what is left in the bracket, I need to do, in this case, I did synthetic division. There are other methods as well. Okay. So whatever method you are doing, make sure that you are completely happy and satisfied that you're getting the same answer, because either you are wrong or I am wrong. We need to be getting the same answer for us both to be right. Okay. Right. Now the next question says, determine the point of inflection of g if it is given that g of x equals minus f of x. All right. So we're going to have to write our g of x, and I'm wondering if I can do it here in a darker color, maybe. For g of x to be equal to minus f of x, it means that it's the negative of the existing function. So all the signs will change. So it's x cubed minus 13x minus 12, right? And we want the points of inflection. In order to find points of inflection, it is second derivative equal to 0. That is the theory that goes with a point of inflection. Right, so the second derivative equals 0. Right, so let's take the first derivative. It will be 3x squared minus 13. And the second derivative is 6x. And if I then put that equal to 0, I get x equals 0. So far, my x is 0, and I do not have my y. I need its partner. So I go back and I sub in into this function. I sub in 0, and I get minus 12. All right. So there is a point of inflection at 0, minus 12. And that counts quite a lot of marks. So it helps if you know your theory. Just remember that you first had to find g of x, which they told you was the negative of f of x. The negative just means change all the signs, multiply through by negative. And then, of course, you need to know how to find point of inflection. Okay, important. Right, now the next question, calculate the values of x for which the tangent to f is parallel. So these are my keywords, tangent, parallel to. Okay, remember parallel means same gradients, same m. Same as this m. And what is this m? It is minus 14. But what is another word for gradients? It is derivative. I need to find the derivative of the function. Remember that when I am finding the gradient to a curve that curves, there will be a different tangent at every single point on the graph. There is a different tangent. In other words, each of those tangents has a different gradient. Okay? There are infinitely many dots, points on the curve. And at each of those infinitely many points, there is a tangent. So the tangents, gradients are ever changing, right? And what represents the gradient anywhere on a curve? The derivative, right? So let's see, we're going to find the derivative of the function, which is minus 3x squared plus 13. That represents the gradient anywhere on the curve. But we want the gradient to be minus 14. So we're going to put this equal to minus 14. So minus 3x squared is equal to minus 27, minus 14, minus 13. I then divide through by negative 3 to get 9, and then I square root. So x will be plus or minus 3. And it says the value or values of x for which the tangent is parallel to the line. So in other words, there are two places, 2 points on the curve where the gradient is minus 14. And that makes sense. A negative gradient lies like this, and there could be another negative somewhere else. So it makes perfect sense that there could be 2 in this case. Right, and they just wanted the values of x. So you've answered the question. They did not want the points. Had they asked you for the coordinates of the points where the tangent is parallel to the line, you would have had to take this and put it back into the original function, because these are points on the original function. Okay. Right, so this is a very good question to go through, hence I chose it, because it covers quite a lot of concepts all in one question. You have to have a good knowledge of your theory. They could have asked you other questions as well. They didn't. They could have asked you for the stationary points. They could have said E is a stationary point and F is a stationary point. Find the coordinates of E and F. They could have, right? They didn't. There are other things that they could have asked, but this is what they asked in this question. 8.4, you will get asked something like that, something to do with the tangent. Maybe not necessarily parallel, maybe perpendicular, or maybe just find the equation of a tangent at a point that they give you. But they'll certainly give you a question with a tangent, definitely in the calculus section. They always do. And this also can come up in paper 2, just in a different section of work, analytical geometry with the circle. All right. Okay, so this is one of the questions that I thought I would go through. I'd like to just stop sharing and just ask if there are any questions first. If anyone has anything that they would like to ask, let me just have a look. Okay, I don't see any maths questions. Is there anything that worries anyone? Anything that they're unsure of? I'm happy to explain in more detail if you're unsure about something, a general concept. All right, it seems okay. All right, now I have another question that I'd like to just bring up as well. And it's a little bit different. Sorry, I need to open it up. I saved it as a file, so just let me find it. There we go. And I'll share it with you now. I just want to make sure I'm in the right place first. Right, there we go. All right. Right, so let's have a look at this one. So now, I purposely chose this one in comparison. This one, you are not given the equation. There are variables in that equation. And invariably, you're going to have to find this B, C, and D. Okay, without even looking at the question, one can assume that you're probably going to have to find the B, C, and D. Okay, so I particularly chose this question for that very reason. Let's see what they're giving you. They say that this is a curve, a cubic function with 3 unknowns. The solutions of f of x equals 0. In other words, where y equals 0, that means the x-intercepts, okay, are -2, 1, and 4. Now, whenever they give you the x-intercepts of a graph, we use this formula. Right? And in this case, there are 3 x-intercepts. So there are 3 brackets. The x1, x2, and x3 represent the x-intercepts. Okay. And that is what you substitute in first. Now, in this case, you can see that the a is 1. There's a 1 in front of the x cubed. So you do not have an a that is anything else. It is a 1. So you can ignore it. And it is x minus -2, x minus 1, and x minus 4. Right. And if we simplify that a bit, x plus 2, x minus 1, x minus 4, we have everything except the x and the y, so that means we can write it in standard form by multiplying it out. So what I like to do is I keep my first bracket and I multiply my second two brackets out. It doesn't matter. You could have multiplied out the first two brackets and kept the last one. It's really immaterial. Use whichever you're comfortable with. Right, so it's x squared minus 4x minus 1x is minus 5x plus 4. Right. Oh, this is an x squared. And then that's x cubed minus 5x squared plus 4x plus 2x squared minus 10x and plus 8. And then we just tidy it up. So it's x cubed minus 5 plus 2 is minus 3x squared plus 4x minus 10x is minus 6x plus 8. Right. So you can see what is joined to x squared. B would be minus 3. Your C is joined to x. There's the C joined to x, so your C will be minus 6. And your D is your constant, the one without any x, which is 8. All right, so there we go. They said find the values of B, C, and D. So you can't just leave it like that. You have to write down B equals, C equals, D equals. That's what they want. All right. So very important that you realize that when you are given the x-intercepts, you have to have the 3 brackets. Okay. You fill in your x-intercepts and then you multiply out. That is if you know that A is whatever it is. Okay, in this case, there was no variable in front of x cubed, so the coefficient of x cubed was 1, right? So A is 1. Sometimes they will put a variable there. So you would have had an A, but that would have meant that you would have had an x and a y, some other point somewhere on the graph besides the x-intercepts, that you could have substituted for x and y and found A. Okay, so just be aware of that. Right, so there we go. An important question. It often comes up in a final exam. And prelims, of course. Right, the next question is calculate the x coordinate of B, the maximum turning point of F. They did not need to say both maximum and turning point. You can see, if they told you it was just a turning point, you can see it is a maximum, okay? And if they say maximum, it is obviously a turning point. So it's a bit of a overkill there with the wording, okay? But the key word there is turning point. The method for turning point is derivative equals 0, right? This is my function. I can now take the derivative and put it equal to 0, all right? So derivative of x cubed is 3x squared minus 6x minus 6. And that equals 0. I can divide through by 3. Remember to always divide through by a variable. Sorry, a constant, common factor. And then this doesn't factorize. So they were even more nasty, okay, or nastier. They gave you one that didn't factorize. So you'd have to use the quadratic formula. So x equals minus b plus minus root b squared minus 4ac all over 2a. So 2 plus minus, and this will be root 12. Oh, sorry, and a is 1. I hope you guys are checking my algebra. So it's 2 plus or minus, and root 12 will give you 2 root 3. And if you divide by 2, you get 1 plus or minus root 3. Right. This one will be your 1 minus root 3, because that will give you a negative. And then you can substitute if you needed your y, you would substitute this answer into the original. Right? That's original. But they didn't ask for that. They just said calculate the x coordinate of b. Okay, so there we go. All right, it's just 1 minus root 3. The 1 plus root 3 would be this turning point. Okay. All right, just be aware. Right, and then they said sketch the graph of f double dash x. That's the second derivative. Okay, now this is the first derivative. So the second derivative would be 6x minus 6. And that, of course, is a straight line. Okay, so you can literally just go and plot two x values, find their partner y, and draw the graph. Okay. And then another nice question, for which values of x is f of x concave up? Remember, concave up means second derivative greater than 0. Right. And the second derivative is 6x minus 6 is greater than 0. So x is greater than 1. 6 over 6. As easy as that. But again, you need to know your theory. All right. Okay, so that's a completely different take on a calculus problem in terms of graphs. Okay, this one had variables in it, values that you needed to find, or B, C, and D. The previous one, they gave you those values, but they asked you to find various items on your graph. Right, so that's that question. And see how many marks these questions count. They count a lot of marks, so it's really worthwhile knowing. Okay, but I see some questions popping up. Okay, synthetic division. Calvin, you're asking into which formula would we substitute the x value of in the inflection? So remember, it's a point, and any point on a graph has an x and a y, okay? And the y comes from the y equals, okay? And the y equals is the original function, okay? So if they're asking you for the point of inflection, you find the x by doing second derivative equals 0, and that x value you substitute into the original that says y equals. AXA, you wanted to ask, the graph of the function ax cubed plus bx plus c has a turning point at minus 1, 0. Is this a different question?
Yes, ma'am, but this question doesn't have 3 variables, so I wanted to know if you can help me solve it.
Is this the whole question, though?
No, ma'am. After that, it says, and cuts
okay,
the y. Okay, ma'am.
Hang on, let me write it down as you're going along, okay? I'm just going to put my whiteboard up. All right, did they say that there's a turning point at minus 1, 0?
Yes, ma'am.
Okay, and the graph is y equals ax cubed
Plus bx plus c.
No x squared.
No, ma'am.
Okay.
And it says, and cuts the y-axis at minus 2.
So the y-intercept equals minus 2.
Then
In other words, the point is 0, minus 2 on the graph. Okay.
It says, show that a is equal to 1, b is equal to minus 3, and c is equal to minus 2.
Okay, cool. All right, so do you see, as soon as you told me that the y-intercept is minus 2, I'm thinking about my theory for y-intercept, which is x equals 0. So x is 0, y is minus 2, is a point on this curve. That means that I can substitute the x and y in. So minus 2 is my y equals a 0 cubed plus b 0 plus c. These will fall away, they're 0, so c equals minus 2, there it is. if I sub it back in, I now have y equals ax cubed plus bx minus 2. Are you happy so far?
Yes, ma'am.
Right. Your other clue is turning points. Turning point is derivative equals 0, isn't it? So, if I take my derivative of this function and I put it equal to 0, what is the derivative? Well, of this, 3ax squared plus b equals 0. And where does it happen? It happens at x equals minus 1. Right? Minus 1 squared is 1 times 3a is 3a, so 3a plus b equals 0. I have two unknowns, so I need another equation. This point is a turning point. And we've done derivative equals 0, but it is also just a point, just like this is a point, which means I can substitute that in there. So when y is 0, x is minus 1.
Ma'am, sorry to disturb you. I don't understand. What did you do when you substituted 3a, then you put minus 1, then I don't understand what you did after that.
This is the x. So when I do turning point, which is derivative equals 0, so I took my derivative of that, I put it equal to 0, but the turning point is happening when x is minus 1. So I need to put the minus 1 in and then simplify. Minus 1 squared is 1, 1 times 3a is 3a, plus b equals 0. So I'm putting this minus 1 into my derivative equals 0. Because derivative equals 0 helps me find the turning point, but I have the x of the turning point. But even though I've got it, I must still do derivative equals 0. It then gives me an equation that I can use to solve. So tell me if you're still unsure about this x.
No, ma'am, thank you so much. I get it.
You get it? Okay, fine. And then this one we'll simplify. Minus 1 cubed is minus 1 times a is minus a, minus b minus 2. And then we can solve these two equations simultaneously. All right. So for example, here b is minus 3a, and then I just substitute it in here. Right? Minus a plus 3a is 2a equals 2, and then divide by 2. So a is 1. And if a is 1, then b is equal to minus 3 times 1. So b is minus 3. And there it is. Right, does that make sense now?
Thank you so much.
So the important thing is that you have to, sorry, I'm fiddling because I'm trying to, my laptop's dying. It's always dying, I'm so busy. It's important that you focus on the keywords, okay? The keywords tell you what to do. Turning point, you must immediately go, derivative equals 0, and do it, right? When they say Y-intercept, you must go, oh, hang on, that's when x is 0. It resulted in me having a point, which I could then sub into the original, all right? So you've got to work with the keywords. Even if you have no clue what they're talking about, you follow the keywords. And you'll be surprised if you know your theory and you use those keywords and the theory that goes with it. You'll be surprised how everything falls into place as you start doing it. Right, happy with that?
Yes, ma'am.
Okay, super. I just want to see if there are any other questions. Nope. Okay, synthetic division. Somebody asked if I could just go through synthetic division again, so let me do that. Right. So if I took something like x cubed minus x squared minus x plus 1, and I wanted to factorize this fully. This, by the way, can factorize using grouping. But we're going to act like we don't know that, and we're going to use the factor theorem first of all. Okay, so if I get something like this, particularly a cubic function, and I need to factorize, I need to think of the factor theorem. The factor theorem says, come up with a factor first. So you use the guessing game. You start with 1. You work out f of 1, f of minus 1, f of 2, f of minus 2, until you get 0. Okay? F of 1, if you sub 1 in, you are going to get 0. Okay, so bingo, it's working. You're getting 0 when x equals 1. That is a root. And therefore, x minus 1 is the factor. So one of the factors of this cubic function is x minus 1. And what you want to do is find what is left so that when you multiply it out again, you get back to your cubic function. To find what's left, we can do synthetic division, for example. Okay? And synthetic division says, write down the coefficients of the function, of the original function, in decreasing powers of x. In other words, from the biggest x power to the smallest, which has none. Okay? This is 1, minus 1, minus 1, 1. I'm going to do synthetic division with the root. Okay, the root goes there. Okay, so I write down my coefficients in decreasing orders of powers of x, and I use my root. I add down 1 plus 0 is 1, and I multiply. 1 times 1 is 1, and I put the answer under the next number. And I do it again. Minus 1 plus 1 is 0. 0 times 1 is 0. Minus 1 plus 0 is minus 1. Minus 1 times 1 is minus 1. And I add. That is what I'm aiming for. If I don't get that, I have made a mistake somewhere. This is what is left in the bracket. I started with an x cubed. I've taken out an x factor, so there has to be an x squared. It is 1x squared plus 0x minus 1. And then obviously this becomes x minus 1, x plus 1, x minus 1, because that's difference of squares. And these two brackets are the same, so they are squared, and x plus 1. Okay, so that is completely factorized. I got this bracket by synthetic division. It is 1x squared plus 0x minus 1. Okay. Right. I just want to see if there are any questions to do with synthetic division. Let's have a look at that first. Ntando Kayize, is that okay?
Yes, ma'am. Thank you.
You understand now, hey? Okay, cool. Just reading the questions. Question 9.2. Just remind me which question it was. What was it to do with?
Ma'am, I think it was finding the turning point. I was kind of unsure about that.
Finding the turning point.
Yes, ma'am.
So in general, I don't know if So I did it on that other sheet, so it won't save. Was it the first question or the second question?
It was the second question.
Second. Okay, so the turning point. Okay, so your turning point is when the derivative equals 0. You have to learn that. Okay, so you have to know that when you read turning point, it is derivative equals 0. So find the derivative. But remember, we found B, C, and D, right? Okay. Does anyone know what B was? Did anyone write it down? Otherwise, I'll just go through generally. So you take the derivative of the function.
Ma'am, B
Okay,
was
and
1 minus root 3.
no, B. B, C, and D. What were the values of B, C, and D?
Oh, ma'am,
Not the
minus 3, and C was minus 6, and D was 8.
8. Okay, so in other words, you were sitting with y equals x cubed minus 3x squared minus 6x plus 8, right? And the derivative would be 3x squared. So power forward, subtract 1. Power forward, subtract 1. Coefficient of x equals 0. And then I divided through by 2. And this does not, minus 2. And this does not factorize. You can try to factorize it, it will not factorize. So you use the formula. Okay. And that's it. You just use the quadratic formula to find those two x values. That value and that value. They only wanted B, but they could have asked for both. All right. Can you just maybe just clarify where you are stuck with the turning point?
Ma'am, it was when we got the derivative of 6x minus 6. So I was really confused on where that came from.
So to get this.
Yes, ma'am.
So it's power forward 3x to the, and you subtract 1. So you're finding derivative, 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 derivative. Do you know how to find the derivative of something with a power?
Not really good, ma'am.
You bring the power forward 3x to the, and you subtract 1. 3
Yes,
minus
ma'am.
1 is 2. So it's 3x 2. And then you bring the power forward. So minus 6x to the 2 minus 1 is 1. And the derivative of an x term is its coefficient. Derivative of a constant is 0. So you've got to know your normal derivatives, eh?
Yes, ma'am.
You have access to the videos, to the other lessons that I've been doing, because it was all to do with the derivatives.
I will go back into it.
Yeah, please, that will help now.
Thank you, ma'am.
Right, super. Pleasure. I just want to check if there's anything else anyone wants to ask. I did that. I answered that one. I did that. What was the question for the sum we just calculated the other girl asked? Divine, I really do not know. Can you explain to me what the question was about first before I try and answer you?
Good evening, ma'am. Excuse me,
Hi.
ma'am. There was a question that the other girl asked, but I didn't quite get the actual question. I only got the sum.
What was it? What was the sum?
TP is equal to -1. That was the coordinates -1 and 0.
Okay, so it was this question. Oh, the one before. All right, she said that you were given, that they gave you this equation. They told you that the turning point is at -1, 0, and the y-intercept is -2. And they wanted you to find A, B, and C.
Thank you, ma'am.
Okay, so this was given, and that was given, and that was given. All right. And go and try it on your own as well, you know, at your leisure, and see if you're happy with it. Okay. You will have access to the video, so you can then go through it again when you need to. All right. Okay, super.
Thank you.
Pleasure. I think I have gotten through everything I wanted to get through. And yeah, I think I've answered everything. There we go. All right, super. Okay, guys, it was nice to have you. I'll probably wrap up the calculus on Wednesday and possibly start working on, I've had 2 requests so far, so I'll entertain the first request first, which was analytical geometry, and then after that, when we've done that for a while, I'll do some trigonometry, and we'll slowly get through everything. I'm sure we're doing quite well.